many have an explanation in detail that they think we have no holes in this explanation for the Pythagorean theorem? Okay, remember I said don't put a squared plus b squared equals c squared. There's no details in there. You got to be detailed. So who has your explanation? You all do, because I saw it written down. So, Kylie? Okay. Okay. Okay, so in a right triangle, you would take leg squared plus another leg squared and set it equal to the hypotenuse squared. Okay, I like that. We can also talk about it's the sum of the squares of the shorter legs, which is set equal to the longest side square. Something along those lines is a great explanation for the Pythagorean theorem. So what does it actually mean to square a side? What does that mean, Kyler? Yeah, you're multiplying that side, whatever that number is, by that same number. So 2 times 2, if your side length is 2. Okay, so let's set this problem up. So you have, let me do it on here. You have a pool that is 3 times its width. Okay, so what do I label in your picture, Danny? 3x and then the other one is x. Good. So whatever the width is, label that x. Then your length is 3 times that. Okay, what else do I need to label it? You need to label the diagonal. Okay, that is 10 times radical 7. Okay, so how do I solve for the length and the width? Kylie? How many set that up exactly like what I wrote on the board? Why are we going over this problem? Okay. Just because it's on the quiz doesn't mean anything. We missed it. We do not know how to do algebra. And we make silly mistakes that we should not because we passed algebra 1. You absolutely need parentheses around every single side length, no matter what it is. Because we are not squaring things correctly. 10 radical 7 should not be 10 times 7. Right? It should be 100 times 7. Because radical 7 times radical 7 is radical 49. Square root of 49 is 7. This is not 3x squared. 9x squared. And then x squared is just that. So now I have 700 is equal to, how many x squareds do you have? 10. You cannot square root from here. You are not allowed to do that yet. Brooke, you have a question? Okay, so we cannot square root 710x squared to get rid of that 2. You cannot do that. So you have to divide by 10 first. So let's 700 divided by 10, or 70 divided by 1, that's just 70, is equal to x squared. So x is plus or minus, but because we're talking to length, it's the positive square root of 70. Can I simplify that? I got 1 in 70. That doesn't get me anywhere. What's half of 70? 35. So 2 and 35, can I take perfect squares out of there? No. Can I divide by 3? No. Can I divide by 4? No. 5? Yes. 5 times 14? No. Can I take perfect squares out of there? No. No. I can divide by 7, but that leaves me with 7 and 10. And pretty much I can go around in a circle and see I cannot simplify. So you leave it as that. Now, that's one length. That is one dimension. So that is what x is. So what's 3x? 3 radical 70. 3 radical 70. Now, it's not 3 times radical 70 times 3. You can't distribute that 3 to that radical. You're just multiplying it by it. So this is what I should see for an answer. Make sense? We've got to get better at that. Okay?
Wait, how do you take the thing I didn't get was how do you take the 10 radical 7 squared and turn that into 100 times 7?
Because what does it mean to square a side?
So
To multiply by itself. So 10 radical 7 times 10 radical 7. You can only multiply the 10s together, and you can only multiply the radical 7s together. So 10 times 10 is 100, times radical 7 times radical 7, which is radical 49. So radical 49 goes down to the 7. Yes, okay. Yes. So you said you technically get rid of it, but you're not technically getting rid of it because you're multiplying it out. So yeah. Gotta get better at this, okay? Alright. So if you notice, this week we do not have a quiz. We have another quiz next week, and then a chapter test, and then it's midterm time. Okay? So you have to really understand these next 3 sections, and then go back to the first 3 for the test. Okay? So we have another quiz and then a test. Alright, so special right triangles are what we're going to talk about in section 9.4. We have 2 types. Okay, the first one, this is what I'm going to start out with. Clearly that is not a triangle, right? It is a square. What do I know about squares? Natalie? Good, they're all right angles. And all the sides are congruent. Okay, stop there. Now, a square is a parallelogram, a rectangle, a rhombus, right? It's all of those. Okay, so I'm only going to talk about one diagonal, because we know diagonals are congruent, they bisect each other, blah, blah, blah. What's the other thing I know about the diagonal in a square? What is that doing? I just said I'm only dealing with one. It bisects those angles. So what does this become? And this is? So this is?
45.
And? Alright. So if you look at this triangle, we have a 45, 45, 90 triangle. What kind of triangle is this? Even more specifically, besides the right, it's isosceles. It is an isosceles right triangle. So you must know that to get an isosceles right triangle, it comes from a square. And it comes from the square with the diagonal, just one drawn, cutting it in half. So you do need to know this. Okay, you do need to know that. Here's what we just said. An isosceles right triangle, it's formed by constructing one diagonal of a square. The resulting 2 triangles are isosceles right. So these right here are your 45 degrees in that one. Okay, so I will ask you where you get an isosceles right triangle from, and you have to be able to tell me it comes from a square after you draw a diagonal in that bisects the 2 angles. So you do need to know all that. Okay? So 45, 45, 90 triangles tend to be really easy because you have 2 sides that are the same and one that's different. What's the one that's different? No, sides. The hypotenuse. The hypotenuse is going to be different. So we essentially have the side to side to hypotenuse ratio, or leg to leg to hypotenuse if we want to get specific. Okay? And usually we'll see leg to leg to hypotenuse. Okay, any questions so far on isosceles right triangles? questions at all? Bless you. Okay, so we're basically going to find a formula that goes along with the ratio of 45 to 45 to 90 triangles, okay, in terms of the side length. So, first up, side lengths in a 45, 45, 90 triangle. My square has lengths of 3, so that means 3, 3, 3 all around. So how am I going to find the hypotenuse? Okay, I know the sides are 3, because that's given. Pythagorean theorem. So to get the hypotenuse, I have 3 squared plus 3 squared is equal to c squared. So 3 squared plus 3 squared, what is that? 18, because that's 9 plus 9. Simplify this down. So we have 3 radical 2. Make sense? Okay, let's look at a square with side length of 2. 2's all around. This will be 2 squared plus 2 squared is equal to c squared. So 2 squared plus 2 squared is 8. And what is the square root of 8 reduced down to? 2 radical 2. See a pattern? What about side length of 1? Okay. 1 times, no, radical 2 for the shortcut. I can take 1 squared plus 1 squared and set it equal to c squared. Well, that's 2. So c is equal to the square root of 2. See the pattern?
Yes.
What do you mean? Going up. Yeah, you will. So if you have a square with side lengths all 6, it'd be 6 squared plus 6 squared equals c squared, which ends up being 6 radical 2. Yep. So, what is our rule? So if we just draw in our 45, 45, 90 triangle, these are the same. So this is x, this is x, this is, the hypotenuse is what? So if I have a 45 to 45 to 90 degree triangle, I have the side ratios of x to x to x radical 2. You absolutely need to know this. This does not go away until you are done with math. I can promise you that. If you're ever. Okay, so you will 100% need to know this rule. Now, why do I label it in that order? Why not x, x radical 2, and x? Like, why do I have to put it in this order only? Not necessarily the A, the B, and the C. I don't really care about that because I could switch around the B and the A, right? Okay? Think about it this way. If I go to the bare minimum, okay, that last case, I have a 1 to 1 to 1 radical 2 ratio. Why do I not want to say 1 to radical 2 to 1? What do you notice about this order? What? Right, basis first. I'm talking actual numbers. Least to greatest. So we list the smallest angles first and then the bigger one, right? Well, I want to do the exact same thing with my side lengths. I want to go least to greatest. Radical 2 is bigger than 1, right? Because, here, Tucker, you have your calculator out. Take the square root of 2. And what do you get? 1.41. That's bigger than 1. So I always want to go least to greatest. Make sense? Okay, that rule you need to memorize. We get another one tomorrow that's completely different. Totally different numbers. So you need to know this one. Okay, you got to start memorizing today. All right, and this is what we wrote up at the bottom. Just this right here. So basically what this is saying in your isosceles right triangle, or your 45, 45, 90, this hypotenuse is basically radical 2 times the side length. Does that make sense? You're basically taking, our x radical 2 general equation and plugging in 1 for what your x is. So the hypotenuse is radical 2 times your length. Instead of being 3 times or 2 times or something like that, we're now saying it's radical 2 times as long. So 1.41 times as long. Make sense? Okay. So between this, basically these two right here, you're going to want to know. Okay, you're going to just want to burn that into your brain. Memorize that. Now, I have a question. If we look at the general case where we have x, and x radical 2, you're going to use numbers a lot. But you could get a problem like this where it gives you variables. And it says solve for the hypotenuse. So, if I didn't know what my hypotenuse was for the general case, what can I just do? No, I want it in terms of the general case. I don't want to plug in any numbers. I just want the x's. So what do you do to solve for your hypotenuse? Pythagorean theorem, right? So if I did not know this, I'm calling that c. So you have two variables. I'm solving for c. So I have x squared plus x squared is equal to c squared. How many x squareds do you have on the left? You got 2x squared is equal to c squared. So now I can square root both sides. So I have c being the square root of 2 and the square root of x squared. What do I know about x squared when I square root it? It becomes x. So now I have c equaling, these cancel off, so x, I can't simplify radical 2, there's how they get the hypotenuse, general case. Okay, now, do you need to remember that and how they get it? No, you just have to remember this right here. But if they give you variables somewhere, you can still solve for it. You just plug it into the Pythagorean theorem. That make sense? Okay. And my reference triangle, which we have already. All right, let's work. So you're assuming that these are isosceles rights. So we have 45, 45, 90. Are we okay not writing in the 45s each time? Okay, so we can just put those arcs there. So x, and what do I have for that vertical one? That's x as well. So how am I going to solve this one? Q? Okay, just take one step back, make sure everybody knows, which I think we do, but we have 2x squared is equal to q, what's 6 squared? Good, 36. Okay, divided by 2, so Jaden, what's 36 cut in half? 18. Okay, so then I have, I want this equal to the square root. Okay, Brady, can I simplify radical 18? Yes. What can I divide by? You can divide out a 9. So this becomes radical 9, radical 2. So what are my side lengths? 3 radical 2. Now, there is another way you can solve this. If you forget any other way that I show you, you always go back to the Pythagorean theorem. That's where you always want to start with. But if you know the general case, so you know in your isosceles right, you have the xx for your legs and the x radical 2 for your hypotenuse, right? Those are your formulas for the sides. Okay? Understand what I'm saying? Those are our formulas. Right? So, they got your hypotenuse to be 6 by plugging in whatever number your x was and multiplying it by radical 2. So from here, this is another way to go. Get x by itself. What do you do there? Careful, we're not timesing it. To get x by itself, I've got to divide. Because this x times radical 2, right? That's what operation is happening there. Right? Okay, so to get out of multiplication, I divide. So that cancels out. So I have 6 over radical 2 is equal to x. Now you know how to do that. Jaden? Well, this radical is in the numerator. So if it's being multiplied, I can't multiply to get rid of it. Yep. So how do I simplify this now? Natalie? Right, you gotta multiply to get rid of that radical in the denominator. So now, x is equal to 6 times radical 2, and what does that bottom become? It becomes 2 because it's radical 4, which is just 2. But, simplify that even further, and we get the same thing. I don't care which way you go. Okay, but does at least one way make sense how to solve for a side? Perfect. Okay, do this one then. I'm going to erase this stuff. So now you're still finding another side, but now your hypotenuse is a little different. So you got to be careful when you go and square this. Some of us look like we're done. Some of us are getting there. How many are using the shortcut? So we're all doing the Pythagorean theorem?
It's really not that much shorter, is it?
Some are. Some will be real short. Okay, so if you use Pythagorean theorem, I have x squared plus x squared is equal to 2 radical 6 squared. So how many x squareds do you have?
2.
You have 2x squared. Now, 2 times radical 6 times 2 times radical 6.
4 radical
4, hold on, 4 times the square root of 36, which goes down to 6, so I have 4 times 6, 24.
I actually had that. I had 24.
Gotcha. Divide everything in half. Half is 24. X is equal to 2 times radical 3, right? Because you can take out a perfect square of 4. Okay, now, shortcut. 2 radical 6 is equal to, well, my general equation, they got that by taking 2 times, or excuse me, some number times radical 2. So get x by itself, divide out radical 2. So now I have 2 radical 6 over radical 2 times radical 2 over radical 2, because we know we can't have that radical 2 in the denominator. So now I have 2 radical 12 over 2, and your 2's cancel off. Okay, so then I have radical 12, which we just found out, that's 2 radical 3. And you're done that way too. Don't care which way you go. The bottom line, you always go back to the Pythagorean theorem. This is the same thing, so I'll skip over that one. I want to go to this one. Because now, these are your side lengths. X is your hypotenuse. So start this one while I erase this and we'll go over it. Okay, so X is your hypotenuse. Radical 3 is your side length. Absolutely. Okay? So if we set this up, it's going to be, now please, please, please put that in parentheses. Radical 3 squared. Put that in parentheses. Is equal to x squared. What's the square root of 3 squared? That is just 3. So I have 3 plus 3 is equal to x squared. How many 3's do you have total? You have 6. Well, 2 3's added together, yes. Okay, so then I have x to be the square root of 6, and you're done. Now, there's a shortcut. This is just x in the general case. This is just x in the general case. So if I want this guy, well, that's x radical 2, right? In the shortcut, or in the, not the shortcut, but the general case. Everybody understand what I'm saying? So now, if I have my x, I just plug it in. So now I have radical 3 times radical 2, because that always stays there because that's the general case. And I'm done because it's radical 6. Either way, I don't care which way you go. So if you have no idea what I just said, perfectly fine. Pythagorean theorem. Just what we did right there. You can also go the shortcut way if you like that way as well. I don't care which way you go. Yep, Tucker?
All three numbers.
It works every single time. Yep, it works every single time. So let's just say in another example, you know, if I got rid of this, if my side lengths are 50, what's my hypotenuse? 50 radical 2, and I'm done. Does that make sense? Because you know what your x is, you can then find by just plugging it in. So really, when this is a whole number, that makes your hypotenuse even easier, because you just take it times radical 2 and leave it. But when it's a radical like this first example was in red, you have to simplify the radicals because you have radical 3 times radical 2, so you want to simplify that down. What do you mean? Right? Because now you have a year under your belt that this makes so much more sense. Okay? Perfect timing.